An entire subfield of chemistry called organic chemistry primarily deals with molecules containing carbon atoms primarily. So organic molecules are molecules that either have that are either hydrocarbons, contain carbon and hydrogen only, or molecules that can be thought of as derived from hydrocarbons. Now it's quite common because of the typical bonding pattern of carbon and hydrogen and the other common elements you'll find in organic molecules. It's quite common to represent these structures with a skeleton structure. So you need to understand and need to know how to interpret these skeleton structures. Now, here's an example of a skeleton structure for a molecule called glycine. It's an amino acid. This is your skeleton structure. When you see a structure like this, okay, the following are implied. There's a carbon that's implied at the end of a line segment. So here's a line segment right here. There's a carbon there at that end of that line segment, unless otherwise specified. So on this end right here, you have a nitrogen. Okay, so here, okay, there's no atom specified here, so that atom is implied to be a carbon. And this atom right here, okay, it's not specified what atom is there, so that atom is implied to be a carbon atom. Okay? So the number of hydrogens are also implied. Okay? And so that the atoms have a formal charge unless otherwise specified. So look, the oxygen here, there's no carbon here because there's an oxygen, the symbol for oxygen is written here, but the oxygen here is given a negative formal charge. So this oxygen over here, on the other hand, has a zero formal charge. This carbon has a zero formal charge. That carbon has a zero formal charge. This nitrogen has a positive one formal charge. The three hydrogens here are obviously have to be attached to the nitrogen because they can only attach to one other atom. Each one of them can attach to only one other atom. So let's expand this structure. Okay, see a more complete sketch of this Lewis structure. So what you would have is something like this. You have your nitrogen, attached to a carbon, that's carbon right there, attached to another carbon, doubly bonded to an oxygen, that's that oxygen right there, and this carbon has a single bond with this oxygen, okay? And what else do we know? This nitrogen has a +1 formal charge, so that means, what do we know about nitrogen? In order for nitrogen to have zero formal charge, it has to have 3 bonding pairs and a lone pair. If it has a +1 formal charge, it has to have 4 bonding pairs, okay? Well, it's already got 1 with the carbon and it's got 3 more with the hydrogens, right? So it's got 4 bonding pairs, so that nitrogen right there means it doesn't have a lone pair. So no lone pair on that nitrogen, okay? Because it has a +1 formal charge. It's kind of obvious already from the fact that it's got 4 bonding pairs around it. Now, the oxygen over here on the right has a 0 formal charge. It already has 2 bonding pairs. 1, 2. So it has 2 bonding pairs. So it needs 2. For it to have a 0 formal charge, it needs 2 bonding pairs and 2 lone pairs. So this oxygen here has 2 lone pairs on it. So that's implied. Okay? What about this oxygen down here? It's got a -1 formal charge. How can an oxygen get a -1 formal charge? It needs to have 3 lone pairs and a single bond. Remember, 3 lone pairs gives it 6 plus half of the bond. The bonding pair is 1. 1 plus 6 is 7. And by itself, oxygen would have 6. 6 minus 7 is -1. So this oxygen has a single bond and 3 lone pairs implied. Okay, so in order for it to get a -1 formal charge. What about this carbon right here? It's got 1, 2, 3, 4 bonding pairs, so that carbon's happy. It doesn't need any more. But what about this carbon over here? This carbon right here. This carbon right here. this carbon has two bonding pairs. So since it doesn't have a formal charge indicated on it, it's implied to be a zero formal charge. So it needs two more bonding pairs. So this carbon must have two more bonding pairs. But bonded to what? It's implied that it's bonded to hydrogen. So hydrogens are implied, carbon and hydrogens are implied. Okay? The hydrogens are implied to, if the carbon has a zero formal charge, you have to add the right number of hydrogens to be consistent with that. So this is the more complete sketch of the structure of this amino acid called glycine. So this is this one right here. What you have over here on the right is the abbreviation for this more complete structure on the left. Okay? So just a quick check. You can do something like maybe if you had like something like this. What would be the formula of this compound, this molecule? Well, there's implied there is 5 carbons. So 1, 2, 3, 4, 5. And then each carbon should have 4 bonding pairs. So this carbon up here has 1, 2, 3, 4. So this carbon needs 2 more. We will give it 4. This carbon will need 2 more to give it 4. This carbon here will have 2 more to give it 4. And this carbon over here will need 2 more to give it 4. So we have hydrogens on each end. Implied. So this is C5H10. You can see there's 10 hydrogens. This is called cyclopentane. The name of this compound molecule is cyclopentane.